Welcome to Unit 5, Lesson 3, where we are going to discuss binomial and geometric random variables. In this lesson, we're going to talk about random variables and determine what exactly is a random variable, how we can compute probabilities involving binomial distributions, and you've actually done some of this before. We're just now officially naming it. We're going to discuss how a binomial distribution can also be normally distributed, and in addition to that, we're going to take a look at geometric random variables. We are going to be taking a look at the normal approximation to the binomial distribution and calculating the probabilities. I just want you to notice here that we will be doing this in class and you will have some questions on it on quizzes and homework assignments. But on the AP statistics exam, you will not do any normal calculations to the binomial distribution. However, they will help you in our upcoming units. So if you have any questions, please feel free to reach out. Let's just take a minute and discuss what exactly is a binomial setting. All a binomial setting is when the same chance process is repeated over and over and over and over again. We're often interested in whether or not a particular outcome does or does not happen. So think about shooting a basketball over and over and over again. You're going to determine, does it get in the hoop or does it not get in the hoop? That would be a binomial random variable because we're doing the same chance process. And it's either going to happen or it's not. You're either going to get in the basket or not get in the basket. Some random variables count the number of times the outcome of interest occurs in a fixed number of repetitions. So all that means, if we're talking about the basketball situation, would be rather than saying I'm going to stand there and shoot until I actually get it in the hoop, we're going to say we are going to shoot the basketball 10 times. That's a fixed number of repetitions. And how many times am I going to get it into the hoop? So yes or no. So each time I shoot, it's either a yes or a no. That is called a binomial random variables. What is key with your binomial random variables is the fact that we have a fixed number of repetitions. So fixed means we're shooting it 10 times, 15 times, 20 times. That's not a open-ended number. There's a fixed trial and we're counting the number of times the outcome occurs. So that just means when I shoot the basketball 10 times, I'm going to count how many times I make it into the hoop. Okay, now a binomial, so we've kind of already talked about this. A binomial setting arises when we perform several independent trials of the same chance process. So when I say independent trials, that means every time you shoot the basketball, each trial is independent of each other. When you shoot the first time and then you shoot the second time, the second shot does not depend upon the first shot. It's like a new trial every single solitary time. When I say same chance process, that means I'm standing in the same spot, shooting that basketball over and over and over again. So I have the same chance of making it because I'm standing in the same spot. And we're going to record the number of times that a particular outcome occurs. So we're going to record whether it makes it in the hoop or does not. Or in this case, we might say how many times do we make it in the hoops. The 4 conditions for a binomial setting are, now you're going to remember this as bins. Okay, so this has to follow bins in order for it to be binomial. So B stands for binary, so the possible number of outcomes are either a success or a failure. So their binary means 2. There are only 2 possible outcomes. Get it in the hoop or not get it in the hoop. When you're driving down the road, see a red car, not see a red car. Okay, so there's only 2 things that are going to happen. I is independent, so the trials must be independent. All that means is whenever you shoot your basketball hoop every single solitary time, the next trial does not depend on the first trial. So knowing the result of one trial does not tell us anything about the second trial. Like when you flip a coin and you get tails, the second time you flip a coin, whatever you got the first time, it doesn't matter. Okay, N stands for numbers, so the number of trials we're going to define is N, and the number of trials need to be fixed. So you need to know how many trials you're going to do. We're going to shoot the basketball hoop 10 times. We're going to count 50 cars. That has to be a fixed number. And then S stands for success, and this is the same probability of success on each trial. So you have to basically, if we're talking about the cars driving down the road, the probability of seeing a red car has to be exactly the same each time. If you're shooting the basketball hoop and from that one particular spot you only have a 50% chance of making it, that probability of success is the same each time. When you flip a coin, every time you flip it, heads or tails are each 50%. Same probability of success. When you roll a dice, rolling a 1 is the same probability every single time. It's 1 out of 6. So if you notice here, we spell bins. So binary, success or failure. I, the trials must be independent. N, it's a fixed number, and the probability of success is the same on each trial. So there's where bins come from. So you want to remember that as you're looking for and recognizing a binomial setting. All right, so in short, the following is what bin means. Remember, if you're asked to verify if something is binomial, you will want to write out all 4 bins, and you want to do so in context. So B, binary. 2 possible outcomes, success or failure. Shoot, get it in the basket or not. Independent, each trial is independent of each other. When I flip a coin, first time I flip it, second time I flip it, whatever I got beforehand does not affect the next flip. N, the number of trials is fixed. I have 5 trials, 10 trials, and I know this ahead of time. In S, the probability of success is the same. When you flip a coin, heads or tails are each 50%. Here's some common errors for binomial settings. So you've actually dealt with binomial settings before, you probably just didn't realize it. And we're gonna get some formulas that are gonna make it a lot easier to do binomial calculations, but oftentimes students don't recognize that they have a binomial setting on the AP exam, which can just cause you to do more work than necessary on a problem. Oftentimes, the free response questions in a binomial distribution are the lowest scored questions, either just for not showing their work or not recognizing that it was binomial. And if you recognize that it is binomial, you need to state, we'll talk about this later, but you need to state that it's approximately binomial distributed or that it is a binomial distribution. If you're unsure how to answer a probability question, so if you're looking through it, check to see if it satisfies the binomial setting because it will make your calculations a lot shorter. If it does, then you're going to use the knowledge you're about to learn to answer questions about a binomial setting. Now, here is key when you're doing a binomial question. Make sure to define what the random variable x is. And when I say x, random variable x is equal to the number of times that you get the basketball in the hoop. X is equal to the number of times that you flip a coin and get tails. Okay, so when you roll a dice, you can get a 1, 2, 3, 4, 5, or 6. You need to define what you're looking for, okay? So here, notice X is the number of 4s in 6 rolls. So we're specifically talking about the number of 4s. Fixed number of trials is 6. And there's 6 different ways I can roll the dice, but X is the number of 4s you're going to get. So we're either success or failure, we're either going to get a 4 or not get a 4. So we're defining what we're looking for in this situation, just like we did with random variables. Okay, so B, binary, success or failure, is 4 or not a 4. I, for our independence, each roll does not change the outcome of the other roll. So if I roll a 4 one time, I still have the same chance of rolling it the next time. N, there's a fixed number of trials or 6 rolls. And S, the probability of success or getting a 4 each time is going to be 1/6. All right, so here's some examples of some binomial settings. So take a look at the first one. You're interested in how many people at your school wear Asics running shoes. Woohoo! You stand outside the gym and look at the shoes of the next 50 people that walk out. Notice how we've defined X to be the number of people with Asics shoes. So let's take a look and see how this satisfies bins or does not satisfy bins. Take a look at example 2. You want to know if Amazon Prime 2-day arrival guarantees it's actually true. You order 15 products off of Amazon and check to see if they come in by the end of 2 days. Our random variable is Y, or the number of products that come in on time. So take a second and see if each of these two scenarios satisfy your bins. Take a minute, pause the video, and then when you're ready to see your answer, go ahead, play, and check the next slide. Okay, so let's take a look at our first one. So example 1, bins, so binary, was either success or failure. So we either had A6 or not A6. Independent is what one person is wearing does not really affect what another person's wearing. N, the number of fixed trials was 50, and S, the probability of success is the same for each person that they were A6. So we don't necessarily know what we don't necessarily know how many people in the population own A6, but we can say it's either a success or a failure. It's basically maybe like a 50% chance that they're wearing A6. That part's a little bit tricky. So let's take a look at the second one. So the bins here was that my Amazon Prime packages arrived in 2 days or it didn't. So success or failure. So one package delivery was not necessarily dependent on another package delivery. So if you think about it, every single solitary, when I get packages, it's not the same driver over and over again. It's just various drivers that are driving around delivering my products. N, I have a fixed number of trials. There's 15 products. S is the probability of getting it in 2 days is the same. Now, technically, it should be 100% because they're promising the 2-day delivery. All right, let's just take a minute and talk about binomial random variables. Consider tossing a coin n times. Each toss gives either heads or tails. Knowing the outcome of one does not change the probability of any other toss. So if we define heads as a success, then the probability of tossing a coin and getting heads is 50% on any toss. So that's telling us that the number of heads in n tosses is a binomial random variable x. Okay, so what is the difference between a binomial situation and a binomial random variable? So a binomial situation was just like what we talked about, okay? We can identify the bins. Now a binomial random variable, that's where we're defining x. We're saying x is the number of blank. So in this case, we're counting the number of successes as defined by x. So when you say x is equal to the number of times I shoot my basket and get it in, that would be a binomial random variable because you've defined what x is. The possible values are 0 to n. All that means is if I'm shooting a basketball 10 times, the number of times that I can get it into the hoop is 0 or 10. So n is the total number of trials. It's not the probability of how many times you get the basketball in the hoop. It's not the probability of how many heads that you get when you toss a coin. It's just the total number of trials, and x is going to define what a trial is, or what a success is. So x is the number of times that you toss the coin and get heads or get tails, or x is shooting the basketball and how many times you actually make it in. Okay, now, so binomial random variable is going to connect to a binomial distribution. So let's just talk about the probability distribution of x is a binomial distribution. So kind of like how we define the normal distribution with the mean and the standard deviation, a binomial distribution is the same thing. So if it satisfies all of my bins, and I've said, hey, I have a binomial random variable because I can define x to be the number of successes, then I have a binomial distribution. And this part is going to be really important. N is our total number of trials, shooting a hoop, getting it in 10 times. P is the probability of success on any given trial. So if n is the number of trials of flipping a coin, let's say 10, P and X is defined as the number of tails we get, then we can say P is the probability of success on any one trial. And we would write that same way you write the normal distribution, only you write it as binomial distribution, N number of trials, P probability of success. Very similar to the way we write normal distribution. We're just saying, hey, this time we have binomial instead of normal.